Hi everyone. In today's lesson, we're going to talk about compositions of functions. When you're doing a compositions of functions, basically what you're doing is you're putting one function into another function. Or in other words, the range of one function becomes the domain of the other. So in this particular example, we would say this f follows g of x is the same thing as f composed with g of x. That's really the definition. This little circle means composition. All right, and this is the definition that if I'm composing f with g, it's the same thing as putting g of x into f of x. I know it's a lot as far as the technical terms, so maybe if we do a couple of examples, it'll make more sense. So if I give you f of x and then g of x and ask you to find f of g of 3, what I'm asking you to do is put g of 3 into f. So you would start at the end of the parenthesis and work your way in. So we're going to do this inside first. So in this particular problem, we're going to do g of 3 first. So I'm going to go ahead and do that right underneath g. So g of 3. So that means everywhere I see an x, I'm going to put a 3. So I have 3 squared minus 2. And we can simplify that. 3 squared is 9. 9 minus 2 is 7. So g of 3 is 7. And this was our first step. So now what we can do is we can replace g of 3 with what it is equal to. So over here, g of 3 can be 7. So really, we can bring down everything else, and we want to find f of 7. So that will leave me to my second step. So now I'm going to go into f and find f of 7. So that means everywhere I see an x, I'm going to put a 7. So negative 2 times 7 plus 7. We can go ahead and simplify that. Negative 2 times 7 is negative 14, plus 7 is simply negative 7. So what you did was you put two steps together to get a final answer. So if I want to write the final answer, f of g of 3, that entire answer is the second answer that we got, negative 7. So we started with g of 3. We plugged 3 in for x into the g function, got a number, replaced it, and then we went into f. So it's like we started from the back, which is this g of 3, and then put that into f. Okay, let's try another example. So here I'm giving you g of x, and I'm giving you f of x, and I want you to find f of g of 5. So I'm asking you to compose them together. So that's the same thing as writing f and then g of 5. So you're basically putting this g of 5 into the f function. And I rewrote it like such. If you make these parentheses a little bit larger, it kind of makes sense that we're going to do this first and then plug that answer into f. So our first step is going to be to do g of 5 and then plug that answer into f. So I'm going to go over here to my g of x function, and I'm going to do g of 5. So that means everywhere I see an x, I'm going to put a 5. So 3 times 15, 3 times 5 is 15. 15 plus 5 is 20. So g of 5 is 20. So we can go ahead and put that here because g of 5 is equal to 20. So this g of 5 becomes 20. And I can bring down everything else. Now I just need to find f of 20. So that's going to be my second step. So here's my f of x function, and I'm going to find f of 20. So that means everywhere I see an x, I'm going to put a 20. So 4 times 20 minus 10. So 4 times 20 is 80. 80 minus 10 is 70. So my final answer, if I want to rewrite it nicely, this is what I was being asked to solve for, f of g of 5. So if I want to rewrite it, I'll say f of g of 5 is in fact 70. The answer that we got from our second step, right? Same thing here, second step answer. Okay, I'd like you to try number 3 on your own and then hit resume when you're ready for the answer. Okay, so in this particular problem, they're asking you to find f of g of 8. So what that means is f of g of 8. So that's going to be our first step. And then f of whatever answer we get will be our second step. So let's go to g of 8. So here's my g of x function, and I want to put 8 everywhere I see an x. So 2 times 8, 2 times 8 is 16, so I want to find the square root of 16, which is 4. So now my second step is going to be to find f of 4. Since g of 8 equaled 4, like I have here, g of 8 equals 4, I'm now going to find f of that. So f of 4, actually, let me use the red to make it consistent. So f of 4 is 5 times 4 squared. Now, you're not going to do 5 times 4 and then that answer squared. You're going to do PEMDAS, so you're going to do exponents first. So 4 squared will be first, which is 16, and then times 5. So 5 times 16, which is 80. So your final answer should have been f of g of 8 is in fact 80. Awesome. All right, let's try a couple more examples. All right, so number 4, I'm saying if f of x is this and g of x is this, I want you to find f of g of x. So we could rewrite it like we always do, f of g of x. So basically, we're taking the g of x function and putting it into the f function, right? But if you notice, this problem is a little different than before. There's no number to do. So we're actually going to take this entire g of x function. So this whole thing, I'm going to replace it in here. So basically what I want to find is f of x minus 9, because x minus 9 is what g of x is equal to. So g of x is equal to x minus 9. So I want to find f of x minus 9. So I'm going to go back to my f function, which is here, and I'm going to plug in x minus 9. So everywhere I see an x, I'm going to put an x minus 9. So 3 times x minus 9, and then I can just simplify. So 3 times x is 3x. 3 minus 9 is 27. So that is your final answer. So if you want to write it nice, f of g of x is equal to 3x minus 27. That was the original function here, what I wanted to find, and this is my final answer. Awesome. Let's try one more. So here's f of x, here's g of x, and I want to find g of f of x. Notice how it's written in this form already. So basically what we're doing in this case is we're putting f, right, that f of x function, into the g of x function. So f goes into g. So we're going to put f of x into the g of x function. So our f of x function is this guy. So if we want to rewrite it, we can, right? This is what f of x is. We could write it as g of x squared minus 5, because this is what my f of x function is. So that means everywhere I see a g of x, this guy, I'm going to put x minus 5. So g of x minus 5, sorry, g of x squared minus 5. So everywhere I see an x, I'm going to put an x squared minus 5. So 6 times x squared minus 5. So I distribute the 6, and I get 6x squared minus 30. So if we want to write down our final answer, this was our original. So we can say g of f of x is 6x squared minus 30. Okay, so why don't you try number 6 on your own and then hit resume when you're ready for the answer. Okay, so problem here was we needed to find g of f of x. So that means we're going to put the f of x function into the g. So f of x into g of x. So if we wanted to rewrite it, so it was g of f of x, right? We can plug our f of x function, 3x plus 5, right here. F of x is equal to 3x plus 5, and I want to find g of that. So if I go and I rewrite my g of x function, which is x squared plus 1, I want to find g of 3x plus 5. So that means everywhere I see an x, I'm putting a 3x plus 5. Now you should remember that we cannot distribute this power. We actually have to write it twice and double distribute. So 3x plus 5 times 3x plus 5, and then plus 1. So I'm going to go ahead and do that math. 3x times 3x is 9x squared. 3x times 5 is 15x. 5 times 3x again is 15x. And 5 times 5 is 25. And then don't forget that plus 1. So these are my like terms, and these are my like terms. So my final answer is 9x squared plus 30x plus 26. Now, you don't have to rewrite it, but if you want to be technical, it should be g of f of x, which is 9x squared plus 30x plus 26. Either way would be an acceptable way of writing the final answer. All right, that's it for tonight. If you have any questions, please jot them down and ask us in class tomorrow. Have a good one.